Okay, this last video for this section is just another example of how the discriminant is used. So my example here, I'm going to find the values of k for which kx squared plus 2x minus 1 equals 0 has two non-real complex solutions. Now, they could do this same thing and put the k in different places. They could have the k as a coefficient of x, or maybe the k is a constant, right? But you'd basically still do the same kind of thing. It's just here, a is k, right? B is 2, c is negative 1. When it says I want two non-real complex solutions, what does it mean? It means I want d to be negative. The discriminant I want to be negative. So I'll take the square root of the negative when I do the quadratic formula, right? So I just write out my formula for the discriminant. D equals b squared minus 4ac. And then I just stick in my numbers with a being k, right? So it's b squared minus 4ac. 2 squared minus 4k times negative 1. Notice, if I multiply a negative number by something on its left, I have to put that negative number in parentheses. Hence, the negative 1 is in parentheses. Okay, always, 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 always. So negative times negative is positive, so of course that's plus. It's 4 plus 4k, and I want that to be negative. Why? Because I want two non-real complex solutions. So I want my discriminant to be negative. So I just write 4 plus 4k less than 0. That's what it means to be negative, right? So I'm just explaining this here, but what you would write would be either just that, or maybe you would just write this, right? 4 plus 4k, the discriminant is less than 0. And then you solve the inequality. This is one of the many reasons we learn to solve inequalities. So, right? And then cross multiply, right? The 4 just goes down there on the bottom. And you get k less than negative 1. That's your answer.